All right, chemistry students. I believe that I have devised a system that will help you with the problems that you've been having in determining what type of nomenclature to use when you have a mixed problem set to do. The way that I originally intended to do that was by having you guys work through the flowchart. Well, what I've decided to do is make it a bit easier on you and to incorporate the flowchart into the problems that will be asked by having you sort the individual questions into categories, as we started to do on Monday. Even more than that, I'm going to make it so that we only need to ask 4 specific questions about any given compound so that we can then figure out what type of nomenclature we need to use on it. The 4 questions we're going to use are: first, is it an acid? Whether or not it's an acid will predict whether we're using standard ionic nomenclature or whether we're using acid nomenclature, which is completely different. So checking this box first is important because it tells us where we need to go. The next question we'll ask is it covalent? Followed by that, we'll determine whether it's binary or ternary, meaning does it contain exactly 2 elements or does it contain more than 2 elements? And last of all, does it contain a transition metal? Answering this question will tell you whether or not your name needs to incorporate a Roman numeral, and will remind you that you need to use the square method in order to solve that problem, in order to determine what the Roman numeral is. So what I'm going to do is I'm going to work through some of the questions on the test right here in front of you so that we can see how this system would work. So let's take number 1, for instance. If we look at this, it is not an acid, so we'll leave that blank. It is not covalent because sodium is a metal, whereas sulfur is a nonmetal, so we know that that's blank. We know that this is binary, so we can put a B here to indicate that that's binary. And we know that it does not contain a transition metal. Sodium is not a transition metal. So what are we looking at? We're looking at simple binary nomenclature. That's the only box that's checked. So if we have simple binary nomenclature without a transition metal, we look at the negative ion. We know since it's binary, we're going to name it with an "ide" ending. So this will be called sulfide. And then we look at the metal. It's not a transition metal, so all we need to do is name it. So we would call this sodium sulfide. By comparison, let's take a look at the next one. We see this, and we see that it is not an acid. We see that it's not covalent because it contains 2 ions, 2 polyatomic ions, in fact. We see that it's ternary, which means that we know to be on the lookout for polyatomic ions, and we see that it does not contain a transition metal. So, if it is a ternary compound, the first thing we do is look for polyatomic ions, and in this case we have 2. We have the first one, which is we know to be ammonium, NH4 positive 1, and the second one, which we know to be carbonate, CO3 2 minus. So, continuing on, we look at the next one. It is not an acid, it is not covalent, it is ternary because it contains calcium, chlorine, and oxygen, and it does not contain a transition metal. So, since we know that it's ternary, we know to look for polyatomic ions. We look at this polyatomic ion. We know that that's derived from chlorate, which is ClO3 minus is chlorate, which we know from Nick the Camel. So we know that ClO2 minus must be chlorite, because removing an oxygen from an 8 gives you an ite. We know the negative ion to be chlorite, and we know the positive ion is not a transition metal, so all we need to do is name it. So this would be calcium chlorite. Now, on to the next one. We see that this is not an acid. It's not an acid because it does not contain H+. We know that it's not covalent because it contains a metal and a nonmetal. We see that it's binary, so we know that we're going to name our negative ion with an "ide", and it does contain a transition metal. So here's what we'll need to do. We know that it's binary, so we know what to do with the negative ion. The negative ion will be named with an "ide". So this negative ion will be oxide. And since we have a transition metal, we know that we're going to need to use the square method to solve. So we'll write out Fe2O3. To do the square method properly, we determine what the charge of the negative ion is. We determine that's a -2 by its positioning on the periodic table. Multiply to gives us a total negative charge of -6 equals +6. We divide that +6 charge evenly among however many positive ions we have. We have 2 irons, so that means that 6 divided by 2 gives us a +3. So we know that this is going to be iron 3 oxide. We know that this is the number that we need to use to put into the compound if there's a transition metal. It's always the amount of positive charge on the transition metal. Next up, going through, this is not an acid. This is not an acid. This is not covalent because it contains a metal and a nonmetal. This is binary, and it contains a transition metal. So we're going to do the same thing as last time. The negative ion will be named with an "ide." And since it's a transition metal, we know to use the square method. PbS2, we know that sulfur contains a -2 charge because of its positioning on the periodic table. Multiply to get a total negative charge of -4. That's equal to the total positive charge of +4. And when that's divided by the 1 lead, all that +4 charge goes onto the 1 lead, which gives us +4. We then know this to be lead 4 sulfide. I'm only going to do the first 10 here, so bear with me. This next one, we know it is not an acid, but we immediately know that it's covalent. As soon as something is covalent, we can stop right there because we know exactly how to name it. We recognize this is covalent because it contains 2 nonmetals. There are no metals in this. Sulfur and chlorine are both nonmetals. As soon as we know that it's covalent, we know that we're going to use Greek prefixes to name. Only when this box is checked, only when the covalent box is checked will we ever use Greek prefixes, meaning that's the only time that we'll use dis or tris or hexas or heptas or anything like that to describe the name. So we really don't care. Once we know that it's covalent, we really don't care about the rest. So we know that this will be 2 sulfurs, so disulfur, and 5 chlorines, pentachloride. In covalent nomenclature, you use Greek prefixes to tell the name. The second word gets an "ide" ending. And as a reminder, we never use mono for the first element. This is water. You really should know that. The next one we identify as HNO3. Since the positive ion is H, we can immediately identify that as an acid, and that means that we need to use acid nomenclature. We should also go through the rest in order to determine what type of acid nomenclature it is. It contains 3 elements, so we know that it's ternary. And obviously it doesn't contain a transition metal because it's an acid. So we take a look at this, and when we have a ternary acid, we need to look at what this ion is called. The negative ion is NO3. NO3 is nitrate, which we know from our Nick the Camel sentence, because we all should have it written on the test. In fact, I'll write it right up here right now. Okay, we know that to be nitrate because Nick contains 3 consonants, so 3 oxygens, and 1 vowel, so it has a -1 charge. So since the negative ion on our acid is a polyatomic ion that ends in 8, that means that we're going to name it as an ic acid. So this will be nitric acid. Again, we'll get into acid nomenclature more extensively on Wednesday tomorrow. Last 2. We look at this. It is not an acid. It is not covalent because it contains a metal and a nonmetal. This is ternary, so we know that it contains a polyatomic ion, and it does contain a transition metal. So, ternary, we know to identify the polyatomic ion, which is this. This is derived from bromate, which we know to be BrO3 minus, because bromate has the same chemical formula as chlorate, which we can derive from our Nick the Camel sentence. We know that if we take an oxygen away from it, that becomes bromite. And if we take yet another oxygen away, that becomes hypobromite. So we know the negative ion is hypobromite. We look at the positive ion. We see that it's a transition metal, so we need to do our square method in order to determine the charge. We know that hypobromite carries a -1 charge. That means the total negative charge is -2. That means the total positive charge is +2. That means that our total positive charge on this cobalt is 2 divided by 1, which is +2. This is cobalt 2 hypobromite. Last of all, we look at this. It is not an acid because it does not start with H+. It is not covalent because aluminum is a metal. This is binary, so we know that we're going to name with an "ide" ending, and it does not contain a transition metal. So we then know that this is nitride because we listed this as binary, and we know that we'll just name the metal because it is not a transition metal. We don't need to mess around with Roman numerals. That's aluminum nitride. So my goal for all of you is that I would like to put this on the test so that you can then categorize the individual questions, which takes a little bit of mental load off of you, so that all you need to be able to do is know how to do the individual types of nomenclature. Know what putting a B in this box means. Know that putting a B in this box means that we're going to end with "ide." In fact, all of our B's, the negative ion ends with "ide." Know that when you have a T, you're looking for a polyatomic ion, and you should be able to name what that polyatomic ion is from memory. If you don't, study harder. You should know that when you check this transition metal box, you're going to need to include a Roman numeral, and you should know how to do this method to find the Roman numeral. You should know that when it's covalent, when this box is checked, we're going to ignore everything else, and we're going to use Greek prefixes to describe the nomenclature. And when this box is checked, we know that we have a bit of work to do in order to solve the name using acid nomenclature, which we'll get into in more detail tomorrow. So I hope that helps. I'm going to upload this to Schoology now. Let me know if you think this is a valid strategy for working through the problems, and I will see you tomorrow.